Today we're going to be learning about something called composition of functions. But before we do that, I want to review what a function is. Remember we looked at a function machine earlier, a function machine looking something like this, where a function is where when we put one value in for x, our input, we're going to get exactly one value out for x. We call that our output. So for this particular example, our function is represented by x squared plus 8. So if I input, let's say if I input 3 into this function, it goes into the function. This is telling us that we're going to square our x, we're going to square the input and add 8. So I'm going to square the 3, which is 9, adding 8 gives me 17. Okay, simple review of what a function is. But let's say we wanted to add another function to this. Let's say this other function is going to be 2x minus 4. Meaning, whatever our output was for this first function, it's going to go down to this other function machine, and it's going to have another process added to it. So in other words, let's go back to this 3. If I put 3 in this first function, it's going to be squared. I'm going to add 8, and that gives me, like we said, 17. And now what we're going to do is we're going to take that 17 and we're going to put it in this other function, meaning we're going to double it, multiply it by 2, and then subtract 4. Well, 2 times 17 is 34. If I subtract 4, that gives me 30. So when I took and put 3 in this first function, it came out and went into the second function and finally came out as 30. Essentially, what a composition of functions does is it does this exact same thing. So let's look at another example. Let's say if we had the equation, let's do the opposite. Let's say if this time if I had 2x minus 4 as my first function, and let's say if I had x squared plus 8 as my second function. This shows us a property about compositions. And let's say again I'm going to put 3 into this function. Well, what this is doing is it's telling me I'm going to put 3 in this first function. I'm going to take whatever that answer is and put it in the second function, and that will give us our final answer. So when I put 3 in this first function, 2 times 3 is 6. 6 minus 4 gives me 2. Well, I'm not done yet. I still have to put it in the second function. The second function again tells me to square what x is and add 8. When I square x, or when I square 2, 2 squared is 4, and 4 plus 8 gives me 12. Which, if you notice, is different. Even though we had the same functions, we input the same value at the very beginning, we got two different answers. This actually illustrates a property that about functions that you'll learn about in your homework. So let's look at this again. Remember, we put 3 inside of this first function. Let's call this first function now, we'll call this function f. We put 3 in that first function, remember we got 2 as our answer, and then we put 2 in the second function. We're going to call this other function g. And then when we put 2 in that second function g, we got 12 as our final answer. Let's use this now, and let's look at our notes for a second. And let's look at what is called the composition of functions. They say the composite g, and then they use this symbol f of two functions f and g, is a function that maps x onto g of f of x, and whose domain is a set of all values in the domain of f, for which f of x is in the domain of g. Okay, let's simplify this a little bit. First, let's go to this. When you see that symbol, this is not a multiplying symbol, it's not a degrees symbol. It is a symbol that just represents the word following, because in math we try to simplify things, just like when you guys are text messaging, you shorten things up so you don't have to type in a whole bunch of things and get your thumb all cramped up. Similar thing with math. all that symbol represents is the phrase following. So when we see this written as it is, it means G following F, or function G following F. Or another way to write it, and this is another way that you'll see it more commonly, is that G is going to follow function f of x. So now let's compare this with the function machine that we were looking at earlier. Now, with this function machine, we put 3 into function f first and put that answer inside of G second. So G, function G, followed function f. So the way that we would write this would be this. G following f of 3 equals 12. Personally, I prefer writing my composition of functions like this, because usually we're not going to know the answer. We're going to see a problem written like this. It'll say G following f of 3 equals what answer? Writing it like this tells me that if I work my way from the inside out, meaning if I work my way from the inside of the parentheses to the outside of the parentheses, I'm going to take 3, put it inside of function f first, take that answer and put it inside of function g last. So let's look at this from a different perspective. Let's say if we had, instead of 3, let's use -2 as an example. Okay, both of these mean the same thing, meaning I'm going to put -2 inside of function f first and put that answer inside of function g second. Remember, function f is 2x minus 4. Function g is x squared plus 8. So to get my answer, I'm going to put -2 inside of function f first. When I do that, 2 times -2 is -4. -4 minus 4 gives me -8, but I'm not done yet. Remember, what I've just essentially done is all I've done is I put -2 inside of function f, giving me -8 as my answer. Now this -8, I'm going to put inside of function g. So it's going to be -8 squared plus 8. Well, -8, when I square it, gives me a positive 64. And 64 plus 8, well, that's going to be 72. That's my final answer. So essentially, in a nutshell, that's what compositions of functions are going to look like. Watch the following videos to watch some more examples of how to use composition of functions.